Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I'd like to remind our listeners that if you're enjoying our show, please take a moment to rate us on your preferred podcast platform. Your support means the world to us.
Absolutely, Sheila, and hello to all our listeners out there. Today, we're continuing our journey through the data modeling chapter in our Introduction to Databases season. We've already covered entity relationship modeling and its components, and now we're going to dive into ER diagrams.
That's right, Victor. But before we get started, I have a little quiz question for our listeners. Ready? Here it goes. In an ER diagram for a library system, what type of relationship would you expect to see between the entities book and author?
Ooh, that's a great question, Sheila. It really makes you think about how different entities in a system relate to each other. Without giving away the answer, I'd say this question touches on some fundamental aspects of database design that we'll be discussing today. Listeners, keep this question in mind as we go through the episode. We'll reveal the answer at the end.
Excellent, Victor. Now let's start with the basics. Can you explain what an ER diagram is and why it's important?
Certainly. An entity relationship diagram, or ER diagram for short, is a visual representation of the entities, attributes, and relationships in a database system. It's like a blueprint for your database, showing how different pieces of information relate to each other. ER diagrams are crucial because they help database designers, developers, and even non-technical stakeholders understand and communicate the structure of a database system.
That makes sense. So it's like a map of our data, right? Can you tell us about the main components we'd see in an ER diagram?
Great analogy, Sheila. Yes, it's very much like a map. The main components you'll see in an ER diagram are, point 1, entities. These are represented by rectangles and denote objects or concepts in the system, like student or course. 2, attributes. These are represented by ovals and are connected to their entity. They describe properties of the entity, like student ID or course name. 3, relationships. These are represented by diamond shapes and show how entities interact with each other, like in roles between student and course. There are also various symbols and notations used to represent more complex concepts, but we'll get to those in a moment.
I see. So, if I understand correctly, we use different shapes to represent different elements of our database structure. That seems straightforward, but I imagine it can get complex quickly. Are there any best practices for creating ER diagrams?
You're absolutely right, Sheila. While the basic concepts are simple, ER diagrams can indeed become quite complex. Here are some best practices to keep in mind. 1. Keep it clear and readable. Don't overcrowd your diagram. If it gets too complex, consider breaking it into smaller, more manageable parts. Point 2. Use consistent naming conventions. This helps avoid confusion and makes the diagram easier to understand. Point 3. Include only relevant attributes. Not every attribute needs to be in the diagram, especially in the early stages of design. 4. Clearly show relationships. Make sure the connections between entities are obvious and well labeled. 5. Use the right level of detail. The amount of detail should be appropriate for your audience and the stage of your project.
Those are great tips, Victor. I can see how following these practices would make ER diagrams much more effective. Now, you mentioned earlier that there are more complex concepts in ER diagrams. Can you elaborate on those?
Of course. 2 important concepts in ER diagrams are cardinality and participation. Cardinality, which essentially means how many, refers to the numerical relationship between 2 entities, like one-to-one, one-to-many, or many-to-many. For example, in our library system, one book might have many borrowers over time, but can only be borrowed by one person at a time. Participation, on the other hand, indicates whether all members of an entity must participate in a relationship. It can be total, all members must participate, or partial, some members may not participate.
Interesting. So, in our library example, every book must have an author, total participation. But not every person who's an author in our system necessarily has a book in our library, partial participation. Is that correct?
Exactly right, Sheila. You've got a great grasp on these concepts. Now let me share an interesting fact about diagrams. Did you know that they were first introduced by Peter Chen in 1976? Chen's work revolutionized the field of database design, and his notation is still widely used today, over 45 years later.
Wow, that is interesting. It's amazing how some concepts in computer science stand the test of time. Speaking of real-world applications, do you have any examples of how diagrams have been used to solve actual database design problems?
Absolutely. I once worked on a project for a large e-commerce company that was struggling with inventory management. Their existing system couldn't handle the complex relationships between products, suppliers, warehouses, and customer orders. By creating a detailed diagram, we were able to visualize these relationships clearly. This led to a database redesign that significantly improved their inventory tracking and order fulfillment processes. The new system could better handle questions like, which warehouse has this product? Or, what's the status of this customer's order?
That's a great example, Victor. It really shows the practical value of diagrams. Now, as we're nearing the end of our episode, can you summarize the key points we've covered today?
Certainly. Here's a quick recap. Point 1. diagrams are visual representations of database structures. Point 2. They consist of entities, rectangles, attributes, ovals, and relationships, diamonds. 3. Best practices include keeping diagrams clear, using consistent naming, and showing appropriate detail. 4. Advanced concepts include cardinality and participation. 5. diagrams have real-world applications in solving complex database design problems. And remember, like any tool, diagrams are most effective when used correctly and in the right context.
Thank you, Victor. That's a great summary. Now, let's reveal the answer to our quiz question. In an diagram for a library system, what type of relationship would you expect to see between the entities book and author?
Great question, Sheila. The relationship between book and author would typically be a many-to-many relationship. This is because one book can have multiple authors, and one author can write multiple books. In an diagram, this would be represented by a diamond shape connecting the book and author entities, with a M for many on both sides of the relationship.
Excellent explanation, Victor. And with that, we've come to the end of today's episode. Listeners, we hope you found this deep dive into diagrams informative and engaging. If you did, please visit crashcasts.com to find more resources and join our Discord community. Your support on Patreon helps us keep creating this content. And don't forget to subscribe and rate our podcast. Until next time, keep learning and happy database designing.